Magandang umaga, hapon o gabi sa inyong lahat. Ako nga pala si Angel, ang iyong first year business IT student. Ngayong araw, gusto ko sa inyo ibahagi ang aking mga natutunan sa aking kolehiyong nag-aaralan. Ang number system, binary conversion of decimal to binary and binary to decimal, and binary computation of addition, subtraction, multiplication, and division. Ang unang pag-uusapan natin ay ang number system. A number system is a way of representing numbers using a set of rules and symbols. It provides a framework for counting, calculating, and expressing quantities. Common number systems include decimal, base of 10, binary, base of 2, and hexadecimal, base of 16. So, the earliest numerals consisted of marks such as vertical and horizontal strokes. For example, the decimal number 1 is represented by a single mark. Like, you can see in the Chinese number, the 1 is just a 1 mark. While number 2 and 3 are represented by 2 and 3 marks respectively. Like in the Chinese numeral number, the 3 has 3 marks. This marking system is evident in Roman numerals and Chinese characters, which use symbols as basis for their numerical representations. The types of number system, which are the unitary system, decimal system, scientific and engineering notation, and rounding off values. Unitary system. The simplest counting system is tally, where each object is represented by a single mark. To make counting easier, marks are often grouped into sets of 5 with diagonal stroke through each set. This system remains widely used for counting and keeping track of items. Like, see this for example. This is what they meant by grouping sets of 5. Like, what you are doing from elementary, like listing the noisy ones, like this: 1, 2, 3, 4 group, and 1, 2, 3, 4 group, like that. Wait. Next is the decimal system. The decimal system has been widely used for counting since ancient times, likely due to its basis of the fingers of human hand. It operates as a code where each distinct quantity is assigned unique symbols. The decimal system utilizes the following digits of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, which are known as Arabic numerals. This system is remarkably simple, as learning this takes basic 10 numerals, and understanding the positional notation system allows us to count to any desired figure. Once the code is memorized, we can easily perform counting lists, the foundation for arithmetic and more advanced forms of mathematics. So here, it is just the fingers on your hand, and each fingers represent a symbol or a number. The scientific and engineering notation. In scientific and engineering computation, we often encounter large or small numbers, and scientific notation provides a convenient way to represent them. A number in scientific notation is written as the product of an integral power of 10 and a number between 1 and 10, in the form of m raised to the power of n, where m is between 1 and 10 and n is an integer. For example, take 226,400,000 can be expressed as 2.264 times 10 raised to the power of 10. If you're asking how do they get this 10 raised to the power of 8, you just count the decimal places from left to right, like 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, this, and this. Punta down. This alone is 8, so They were, that's where they get the 8. Sorry for misstuttering. And 3 billion can be expressed as 3 times 10 raised to the power of 8, simplifying the representation of large numbers and making calculation more manageable. And the last number system is the rounding off values. Rounding off is the process of reducing the number of digits in numerical value by dropping or eliminating one or more of the final digits on the right. This is typically done to simplify calculation by retaining only the significant figures required for the Fourier computation. Report final results with a suitable level of precision, avoiding unnecessary detail. Conform to specific numerical standards or convention. By rounding off, we can present numbers in more manageable and meaningful way while maintaining sufficient accuracy for intended purpose. For example, you have this number 17.181. This will be retained because 1 is less than 5. Yes. But if 1 is greater than 5, we're gonna round up, and the result will be 17.19, like that. Next topic is the binary conversion of binary to decimal and decimal to binary. Convert decimal to binary, you just have to divide it by 2. Like 39 divided by 2, the quotient is 69 because that's the result. And there is a remainder of 1. And 69 divided by 2 is 34. Right? Yes. 34 is the result of 69 divided by 2, and there is the remainder of 1. 34 divided by 2 is 17. That's the result of that equation, and there is no remainder, so it's 0. And 17 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. And 1 divided by 2 is 0. And to get the binary conversion of this, you just have to write this from bottom to top, like 1, oops, again, 1, 0, 0, 0, 1, 0, 1. That's the result of that. Okay, that's the conversion of decimal to binary. To convert decimal to binary, we will just have to divide the number by 2. For example, 8. We're finding the binary, the binary of 8. So we're just gonna have to put 8 here, divided by 2, and find the quotient and remainder of it. Remainder. Sorry for my handwriting, it's hard to draw on phone. So 2 divided by 8 is 4. 4 times 2 is 8. 0. The quotient is 4 and the remainder is 0. Oops. 4, 0. Next, the 4 and the 0. The 4 divided by 2. You will just continue this until you get the 1 divided by 2, like that. And let's complete this. 2, 4, 0, 0. The quotient is 2 and the remainder is 0. 2, 0. Next is 2 divided by 2, 1, 2, 0. The quotient is 1 and the remainder is 0. Oops. 1, 0. And last 1 divided by 2. So it's not possible because we're just gonna put a point here. If you divide it this into your calculator. It's just easy. 0, 1. Magic. And the binary of 8 is, wait. To get the binary, you'll just have to read this from bottom to top. So the binary of 8 is 1, 0, 0, 0. To convert binary to decimal, we'll need to use the expanded notation. Take the examples earlier, the 1, 0, 0, 0, and let's check if it's the result is 8. Like the notation of which number this is 0, 1, 2, 3. 1 times 2 raised to the power of 3 plus 1 times 2 is 0. 0 times 2, 0 times 2 raised to the power of 2, 0 plus 0 times 2 raised to the power of 1 plus 0 times 2 raised to the power of 0. Let's continue the computation. 1 times 2 raised to the power of 3 is 8. If you're asking how to get that, just do this. 2 times 2 is 4 times 2 is 8. That it's continuous. Plus 0 times 2 raised to the power of 2 is 4. That's 4. Plus 0 is times raised to the power of 1 is 2. Plus 0 raised to the power of 0 is 0. 1 times 8 is 8. Plus 0 times, you know that anything divided by 0 is 0, so let's just shortcut that. 0 plus 0 plus 0 is equal to 8, and that's the answer. Now that we are done with binary conversion, we will continue to binary computation. In addition, we are following some rules. The addition of binary. 0 plus 0 is 0. 0 plus 1 is 1 is equal to 1. 1 plus 0 is equal to 1. And 1 plus 1 is 0, remainder 0. Remainder 1. Let's make an example of that. Like 1, 1, 1 plus 1, 1. 1 plus 1 is 0, remainder 1. And 1 plus 1 is 0, remainder 1. And 0 plus 1 is 1. And 1 plus 1 is 0, remainder 1, and breakdown 1. So the result is 1, 0, 1, 0. Another example. 1, 1, 1, 0, 8. 1, 0, 1, 1, 0. Let's compute this. 1 plus 0 is 1, and 0 plus 1 is 1. Bring down 1. That's the solution. Resolution. That we are finished with addition, let's do subtraction next. In the same, we will have to follow a rule. 0 minus 0 is equal to 0. 1 minus 0 is equal to 1. 1 minus 1 is equal to 0. And 0 minus 1 is 1 bar 1. Like this. The example there, let's use the example from earlier. So 1, 0, 1, 1, 0. 1 plus 1 minus 0. 1 minus 0 is 1. And 0 minus 1, we can wait, how we can use this? We can compute, but we can borrow 1 from its nearest number. So this cancel 0, and to and the result will be 1 because you borrowed 1 from the nearest number, and the answer is 11. That's all for subtraction. Let's do multiplication next. Multiplication, same with the rule. 0 times 0 is equal to 0. 0 times 1 is equal to 0. 1 times 0 is equal to 0. And 1 times 1 is equal to 1. Alright, let's do this. Example 1, 1, 1, 0, 1 divided by, but we divide. 1 times 1 is 1. 1 times 1 is 1, 1. And 0 times 1 is 0, 0, and 0. Let's compute that. Now we have to use the addition, same rule with addition. Let's bring down 1. 1 plus 0 is 1, 1 plus 0 is 1. The result is 1. That's all in multiplication, and let's move on to the hardest part for me is division. Division. The rule in division is similar to wait. So division is kinda hard for me, but I will try. Let's try to compute 1, 1, 1 divided by 1, 1, 0. We cannot divide 1, 1 by 1, so let's take these two. So 1, 1 divided by 1, 1, 1 is 1. 1 times 1, 1 is 1, 1. 0. Bring down 0. 0 divided by 1, 1 is 0. And 0 times 0 is 0. 0. 0. And the answer is 1, 0. That's the answer. That's all I can do in division because I'm not really familiar with this, but I will try next time.